Ohio Minasan. So this is a problem from AIME 1986. It's problem number 5, and it asks the question: what is the largest positive integer n such that n cube plus 100 is divisible by n plus 10? So we want n cube plus 100 to be n plus 10 times some integer, right? And for this I will provide two solutions, one that I did and another that I found on the internet that I thought was also good. So since we have two unknowns, sort of, because n can be anything, n is a positive integer, so since we have these two, what we can do is we can say that n cube plus 100 divided by n plus 10 equals something, just like how 11 divided by 5 is 2 multiplied with 1 over 5. Similarly, we can break this up. So n cube plus 100, let me do it over here. So what I'm doing is I am dividing it n cube plus 0 n square plus 0 n plus 100 divided by n plus 10. In order to cancel out the n cube, we need to multiply this by n square. So this would be n square plus 10 n cube plus 10 n square to give us negative 10 n square, and then we again have to multiply it by negative 10n to give us negative 10n square, negative 100n to give us 100n plus 100. Now at this point we really want to cancel out the n, so what we can all further do is multiply this by 100, so plus 100 to give us 100n plus 1000, and this leaves a remainder of negative 900. In other words, n cube plus 100 is n plus 10 multiplied with n square minus 10n plus 100 minus a 900. So what this means is that n cube plus 100, when you are dividing n cube plus 100 by n plus 10, you will be 900 away from reaching n cube plus 100. So let's draw a number line. Let's say this is n cube plus 100, right? And let's say you are making jumps of n plus 10, right? This is, you can think of multiples as jumps. So for example, a multiple of 2 is like making a jump of plus 2 and then a jump of plus 2 and so on. So you're making jumps of n plus 10 and you're making them this many times. Let's say you do this and you end up somewhere over here. So in other words, this much is n plus 10 multiplied with n square minus 10 n plus 100. And according to our equality that we found here, we can see that this much would be 900. So you are 900 short of reaching n cube plus 100. Now the claim I am making here is that n plus 10 must divide 900 in order for n plus 10 to divide n cube plus 100. If you want to see that algebraically, so if n plus 10 divides n cube plus 100, that would be n plus 10 with some integer. Now this would equal n plus 10 with this integer minus 900. Now if 900 is divisible by n plus 10, so 900 will be equal to n plus 10 multiplied with some integer. In other words, this whole equality is in terms of n plus 10. And so you can basically merge these two boxes, that n plus 10 multiplied with something is equal to n cube plus 100, and hence it will be a multiple. If you want to see this on the number line, well, if n plus 10 is a multiple, if n plus 10 divides 900, it will, by just making that same jump, it will be able to perfectly cover this 900 gap. So for example, let's say n plus 10 is equal to 30, so n would be 20. Now you are making jumps of 30 and you keep making them this many times, and now you are short of 900, so you can keep on making those same jumps some 30 times and you will eventually get here. So you are constantly making jumps of n plus 10 and then you eventually reach n cube plus 100. In other words, this is a proof that n plus 10 would divide n cube plus 100. But if you want to see a similar logic, let's say this is 100, you're making jumps of 10 over here, 10, 10. If you perfectly reach 100 by making those same jumps, then that would mean that 100 is divisible by 10. And so now we're really done with the question, because our claim was that n plus 10 must always divide 900 for n plus 10 to divide n cube plus 100. So now we have to ask the question, what is the largest n such that n plus 10 divides 900? Well, that's simply when n plus 10 is equal to 900. In other words, n is equal to 810. What you are doing is you're making jumps of 900, some uh, some 8 110 square minus 10 8 110 plus 100 times this thing. So you're making jumps of 900 some this many times, and then you are left with some 900 more in order to reach 890 cube plus 100. So you can just move one more, you can just jump one more time, and this would prove that this would be a multiple. To put it in more solid terms, n cube plus 100. So if n is, sorry, this is meant to be 890. If n is 890, then this would be 900 multiplied with something minus 900. In other words, n cube plus 100 is 900, this thing. And in other words, n cube plus 100 is 890 plus 10 multiplied with this integer. So this is just n plus 10, and hence we are done. Now for the other proof, number 2, I would first have to prove that if A divides C, if A divides B and A also divides C, then A will definitely divide B plus or minus C. Now the simple proof of this is easy to see, but to prove this, let's say if A divides B, B is quotient times A. Let's say quotient 1 times A. If A divides C, then C is quotient 2 times A. So B minus C would be quotient 1 times A minus quotient 2 times A. So you can take the A common, and it would be quotient 1 minus quotient 2. And of course this is an integer, this is A, so this whole thing is divisible by A. In other words, B minus C is also divisible by A. So here we want to prove that n plus 10 divides n cube plus 100. And so if we go back to the long division that we did, n cube plus 100 should equal n plus 10, n square minus 10n plus 100 minus a 900. So we can send the minus 900 to the other side to give n cube plus 1000 is equal to n plus 10, n square minus 10n plus 100. And so we can conclude another divisibility by this, that n plus 10 must also divide n cube plus 1000, because this thing is a multiple of n plus 10, and n cube plus 1000 is equal to this. So 1000. So n plus 10 divides n cube plus 1000, and n plus 10 divides n cube plus 100. So we can very conveniently say that n plus 10 must also divide n cube plus 1000 plus 1000 minus n cube plus 100. In other words, we're reaching the same conclusion that n plus 10 divides 900, and the largest possible n that divides 900 would be n equals to 890, and we are done. QED.